This video is designed to help you understand what you can and can't assume in a diagram, and then we also take those ideas and use them in proofs and theorems. So the first thing to review is what you can assume. You can assume that things have straight lines and angles. You can assume that points are collinear, meaning that they're in a straight line if they look like they're in a straight line. You can assume betweenness of points, so if one point looks to be between two other ones, you can assume that. And then you can also assume relative positions, so if something looks like it's above another point, that you can assume. The you can't assume column is there for two reasons. The first is that a lot of times your eye can't tell the difference. You have that human error, so you can't necessarily tell when things are right angles or congruent. But the other reason is that in geometry, not everything is drawn exactly to scale. So you can't assume things like right angles because it might not be drawn to scale, but it also might be an 89-degree angle and your eye cannot tell the difference. For those same reasons, you can't assume that segments or angles are congruent. And you also can't assume relative sizes. So if one shape looks to be double another, you can't necessarily assume that either. All right, so we've got all these things that we can and can't assume, and let's just review them. So copy this in your notes. All right, let's go over what you can assume. So you can assume that ACD and BCE are straight lines. You can also assume that angle BCE is a straight angle. You can assume that CD and E are not collinear. You can assume that C is between B and E. And you also can assume that E is to the right of A. Here are the things that you can't assume. You can't assume that BAC is a right angle. It might look like a right angle, but it might not be. You can't assume that CD is congruent to DE. You can't assume that angle B is congruent to angle E. You can't assume that angle CDE is obtuse. You can't assume that BC is longer than CE. So, big deal. Why do we need to know all this? Well, we're going to use these ideas to prove these things called theorems. And theorems are math statements that you can prove to be true. So what we do with our theorems once we prove them is we use them to solve problems. So what I'd like you to do is create a section in your notebook where you list all the theorems. Because what you're going to have to do is memorize the theorems and use them to solve problems. So let's look at our first theorem. All right, so our first theorem is if two angles are right angles, then they are congruent. Now, you might feel like you can assume this because you've been using this concept for all of your math life, but years ago, somebody proved this to be true, and so we're at the point where you can't assume things. You actually have to prove the congruency. So when you're trying to prove a theorem, they're usually going to give you some things. So for example, our given here is that angle A is a right angle, and we also are given that angle B is a right angle. So here are the pictures. And what we have to prove is that angle A is congruent to angle B. So we've got our picture, we've got our givens, and here's what we're trying to prove. So when we're doing a proof, we have this thing called a two-column proof. And on the left side, we put our statements. And on the right side, we put our reason why that statement is true. So for this one, our first statement's going to go like this. Angle A is a right angle. And why do we know that? We know that because it was given. So reason number 1 is given. Number 2, we know that the measure of angle A is equal to 90. How do we know that? Because if an angle is a right angle, then it measures 90 degrees. That's the definition of a right angle. Right? Statement number 3 is going to do basically that same thing for angle B. So angle B is a right angle. And we know that because it was given. Statement 4 is that the measure of angle B equals 90 degrees. And the reason we know that is because you can repeat statement 2, but actually let's just write same as 2. Okay, our next statement, statement number 5, is going to say that angle A is congruent to angle B. And we know this because if two angles have the same measure, then they are congruent. Right? The definition of congruent is when two angles have the same measure. So that's basically the definition of being congruent. And what we can do, now that we have proven this theorem to be true, we can use this concept to solve problems. All right, let's check out another theorem. Okay, so the next theorem is if two angles are straight angles, then they are congruent. So it's similar to the previous theorem, different types of angles, so we have to prove it. But actually what I want to do, instead of proving this to be true, I want to show you how we use it to solve other problems. So for this one, we have this picture, and we're given just the diagram. We don't have any other information. And instead of saying prove, it just says the conclusion that we have to come to at the end. And we have to come to the conclusion that angle EFG is congruent to angle HFJ. Okay, it's always good to start off your two-column proof with the givens. So first thing that we're given is the diagram. And the reason is that it's given. The second thing that we're going to do is we're going to go through some assumptions that we have. So one thing that we are able to assume is angle EFG is a straight angle. And the reason we can do that is we can assume from the diagram we can also assume the other line as well. So we can assume angle HFJ is a straight angle. And same reason. Okay, we're almost there. The last thing that we're going to do is to use those statements to come to our conclusion. So statement number 4 is that angle EFG is congruent to angle HFJ. And the reason we can do that is because of we have this theorem that says if two angles are straight angles, then they are congruent. So unlike the first example that we just did, where we proved the theorem correct, in this example, we had the theorem and we used it to solve a totally different problem. All right, let's do one more two-column proof. Okay, copy this down, and I want to do it a little differently. I'm going to give you the statements, and you're going to give me the reasons. Okay, my first statement is that angle RST equals 50 degrees. Pause the video if you need to. Tell me why that's true. Well, it's true because it was given. Statement number 2. Angle TSV equals 40 degrees. Pause the video if you need to. Tell me why that's true. Well, it's true because it was given. Statement number 3. Angle RSV equals 90 degrees. Pause the video if you need to. Tell me why that's true. Well, it's true by simple addition. Right? 50 plus 40 equals 90. Statement number 4 is that angle RSV is a right angle. Tell me the reason for that. The reason is the definition of a right angle. If an angle is 90 degrees, then it's a right angle. Statement number 5 is angle X is a right angle. Pause the video if you need to. Tell me why that's true. It's true because it's given. And statement number 6 is angle RSV is congruent to angle X. Pause the video if you need to. Tell me why that's true. The reason is our friendly theorem. If two angles are right angles, then they are congruent. So again, here we are using our theorem, which we have proven to be true, to solve a problem.